This is Unit 3, Section 2, Problems 11 through 20. Number 11 I didn't draw, but you see the domain there. It goes from negative infinity to infinity. It's the axis. The range is the number, negative 4, because there's a dot down where the y is negative 4, and then it goes from negative 2 to infinity, including negative 2. 12 is from the picture there. Negative infinity to infinity uses all the x's. The range, negative infinity up to 3. 13 and 14 and so on through 20, you need to do the domain on all of them. X-intercept if you have one. Y-intercept if you have one. Do a table. Do your graph and your range. And the vertex, if it's a parabola or absolute value, you need the vertex. Number 14, h of x equals 4 minus x squared. The domain is all real numbers, negative infinity to infinity, because there's no x in a radical or in the denominator. The x-intercept, you set 0 equal to 4 minus x squared, and then you factor 2 minus x, 2 plus x. And so my two numbers are negative 2, 0, and 2, 0 for my x-intercept. Y-intercept, you always put 0 in for x, so it gives us 0, 4. Then I made my table by picking out random numbers around the vertex, and the vertex, number 7, probably should be found sooner, but is negative b over 2a. And since there is no b, the b is next to the x term, and there's no x to the first, so it's 0 over negative 2. So 0 is your x-coordinate, put 0 back in, get 0, 0. Then plot your points there, starting with that vertex, because everything's around the vertex. Then your range, you look at the graph, negative infinity to 4. Number 15 is also a parabola. Do all 7 parts. Number 16 is a cubic polynomial, x cubed minus 4x. Domain is all real numbers, because no x is in a radical, no x is in the denominator. The x-intercept is found by setting 0 equal to x cubed minus 4x. Then factor, as I've shown here. 3 x-intercepts, 0, 2, and negative 2. Then your y-intercept, put 0 in for x, we get 0, 0. Then number 4, I make a table with random numbers from around our x-intercepts. And this is what a cubic polynomial looks like. The range, looking at that graph, goes from negative infinity to infinity, all numbers used. And you don't need a vertex on cubic polynomials. It takes calculus to do that. Number 17, I went ahead and did, because a square root graph, your domain, x minus 1, inside that radical, has to be greater than or equal to 0. So x is greater than or equal to 1. X-intercept, I set the equation equal the 0 equal to square root of x minus 1, squared both sides, found that I get 1, 0 as my x-intercept. My y-intercept, when I put 0 in for my x, I get the square root of negative 1, which is not a real number, so no y-intercept. Then I took some numbers and put them in for x, starting with my first number that I can have, 1. Then I put 2, 3, 4, 5 in there to give me my numbers, and then I plotted them. My range is the first number on my y that I had was 0, going up to infinity, and there's no vertex, just a starting point on square root graphs. Then number 18 is an absolute value, very important there. The domain, again, no x's in the denominator or in a radical, so all real numbers. Negative in the x-intercept, remember, we set this equal to 0 and solve this as we do on absolute values. The absolute value of x minus 1 equals 2. We found our two values, negative 1 and 3. Just like we solve, you set 0 equal to this equation and work it out. Your y-intercept, put 0 in for your x, find your y. Then on your table of numbers, the first thing I needed is number 7. I set what was in the absolute value, the x minus 1, the x minus 1 equal to 0, and then that gives me 1. That is my x-coordinate of my vertex, whatever thing is around. That is this point over here. So 1, negative 2, when I put that 1 back in the equation, I find that it gives me negative 2. And so start with your vertex on your table on absolute value and parabolas. Then go on each side of it. 1 to the right, 1 to the left, 2 to the right, 2 to the left. Get your numbers. Then plot them. Okay? So the vertex needs to be found probably before you do your table. And then number 6, look at your picture to find your range. Not y-intercept, to find your range. It's from negative 2 to infinity. Number 19 is just like number 16. Number 20 is like the one we just did. So please follow along. The work is shown there. Okay, that is number 20.